Hi, this is Ali from QualitySpectrum.com. I recently gave a talk at the PSQC 2018 conference, and the talk was very well received by the audience, so I thought of sharing it with the audience here at the channel. In this presentation, we take an example of a hypothetical tester who starts his testing career and faces typical challenges which testers face today, and he learns how to overcome them and progress in his career. I hope you will enjoy it, and without further ado, let's get into it. So the presentation for today is to be technical or not to be, that is the question. The presentation is all about how to become a technical tester. So before we go into the presentation itself, I'd like to ask yourself the question, how many times have we thought about or discussed, is there any future of exploratory testing? Is it ending? Or you might have heard the question of which everyone tries, we all try to learn automation. So how to learn automation? And these are very common questions that we come across. And the reason I feel for this question is naturally that the perceived career path of a tester is that we start with exploratory testing, and that's where we begin with. And then the next step, logical step we see is automation, and in between, then we can move up to management, or you can perhaps sometimes just go directly to management. But that's generally how testers feel that their careers should progress. I'd like to give an alternative career path instead of this, and I call it that the first step when we start off, we are really, there's nothing exploratory or called exploratory or manual testing. We are unfortunately for the most part non-technical, and since we are non-technical, we are not able to add enough value for the company, or for the company to pay us enough that we are providing enough value towards the product. And with time, what we are really trying to get to is to become more technical. Automation is just a byproduct of being technical. And the last step is being technical and having leadership skills. Management is something of the past century. It's all about leadership now. So hence the question is to be technical or not to be, that is the question. Now, for this presentation, I'd like to introduce you to our hypothetical tester, Asim here. He is a fresh graduate and he is starting off his testing career. And he will be sharing a few of his testing stories with us as to how he progressed through his career and the challenges he faced. So the first story he's going to talk about is where he got hired by a car manufacturing company. Now, as soon as he joined the job, he was given some training, and then he started off directly with functional testing of the car. And as any good tester would do, he started jotting down the requirements and getting test scenarios from those requirements and creating test cases and doing functional testing is what he started with. And that's how generally we all start. So including within functional testing, they thought of they should try to use the product as an end user would. So they would drive the car, test all the functions of the dashboard, and then okay, so they've done enough driving and playing with with the signals and with the infotainment system and whatever they could find on the dashboard. So they've done basic tests around everything they can see, and then they think there should be some more testing, we haven't covered enough. So they try to drive it at high speeds, zoom around, zip around, cutting off people, just to test the limits of the car, going it above the acceptable speed limits, just to add more coverage. And then, well, the thing, there's we need to do some safety tests. So let's do the check the safety features of the car. So let's ram the car into a wall and see if the mannequin's head is still intact, right? So in all of this, just in an attempt to get enough coverage. And now they can't think of anything, so they also might turn to Mr. Bean to learn some extreme load and stress testing that he has done with his Cooper, right? So after all of this, and they're still not able to find any significant issues, whatever they found has been fixed, and now it's finally time to release the software. So everybody is excited and happy, and they've released the product, and they've released the launched the car in the market, and they're all very happy. However, Asim still feels deep down that there was some things that they weren't able to test, because there's a lot of functionality in a car which you really cannot test just by driving it, right? Or smashing it into a wall. So he still, in the back of his mind, has this feeling that we haven't really done the job well. And long behold, there turns out that there was some specific functionality in the ABS braking system of the car which they did not test enough, and there is a software bug over there, and this is an actual issue which Toyota came across in I think 2010 2011, that they had to recall 2.1 million cars due to a software problem which had something to do with the braking mechanism of the car. You can imagine how severe that was. So and just since they weren't able to test that, what they thought, that thing got released, and the whole testing team is in a big heap of problem. Well, so the lesson learned here is that testers must be technical. You need to understand what's going on under the hood so that you can go in there and test it, because you cannot test everything just by doing functional testing. So that's what our tester learned, and then unfortunately I had to move to another job. And so the next job is that he gets hired at a company who have a hybrid app. And so let's talk about what a hybrid app is first. It's where, for instance, you might have used LinkedIn on your web browser on your laptop. You can open the same website on your mobile phone's browser. You can open it in Chrome browser. It would appear a bit differently, and you can also download the app from Play Store, and you can install the app that way. And so the application can be accessed on all devices, and it has a different interface for each of them. So that's called a hybrid app. So it has a mobile end and a regular web end, and you can access the application both ways. So this is the kind of application our tester has been hired into. And so, as any good tester would do, he starts off with the front end and functional testing again. So he does all the functional tests, getting things from requirements, exploratory testing. He does even UI design testing to make sure that the aesthetics of the application are good. Testers have a good feeling about it. He also does some compatibility tests over there to make sure that it's working on different platforms, all in the spirit of trying to get enough coverage so that he does not miss anything, right? Well, he still feels after all of this that he hasn't done enough, and there's still something that's left out there, without having any clue apart from this gut feeling that he has that they've missed things again. He doesn't know what really to do, so he finds out, looks for a experienced guru tester, and he asks our experienced guru tester here that how to get maximum coverage, test coverage for my application. So he suggests that you should try and understand your product's technology stack. So you'd have a front end, and so then he naturally goes and tries to understand how the web application or the application is working. So it has a front end, then he learns there's something called a back end, and then there's this database as well involved in the back end. And he then tries to understand all these different components. Also, he realizes that the amount of code usually written at the front end is just 20%. 80% of the code that is written is, for most cases, it lies at the back end. So naturally, he has been putting all his effort on the front end, whereas 80% of the code is written at the back end, which he is not directly focusing his attention at. So he also learns that there is something called the automation pyramid, which alludes to the same concept, where it suggests automation checks to be written, just 20% of them focusing on the UI level and 80% of them to cover API and unit level or DB level tests. So with all of this knowledge, then he starts to learn how the different components of the technology stack work. So he starts with the front end, and he learns that his application's front end is developed in AngularJS. He finds out that what he sees on the browser is called the user interface, but behind the scene there is something called the DOM, the data object model, which actually has all the web page written down in code, in HTML code over there, which he sees actually on the user interface. And there is also something called the JavaScript interpreter, which is running the client-side scripts that we have written for our application. And then there's something called the browser engine. So the basics of the browser architecture and how these different modules and functions work with, and features work with one another, and how he can insert test probes, or he can access directly objects from the DOM. He can make sure add more coverage to his client-side scripts, because now he knows what scripts are running on the JavaScript interpreter, and he can call them and test around its boundaries and so on and so forth. He does the same thing with his mobile front end. So with the Android app, this application has an Android app, and he goes through the application. He learns that there's something called the application framework and a layer called the library. So he goes through the all these modules, layers of the Android OS, and he learns that he can, like the browser, he can access backend or functions directly from the library or from the application framework, and he can test areas which probably he might not have been able to just from the user interface of the app. So well, he's all excited about that, and then he moves on. He turns his attention to how the front end and the back end are interacting with one another. So it turns out that there is something called the HTTP messaging protocol. And so what happens is, when we send a request from the front end, it generates an HTTP request, which is sent back to the server. And the server does the processing, and whatever response it has to create, it creates a package called the HTTP response against the request that it received. The response is sent back to the front end, and that's how he's seeing information on the on his web page, on his laptop or on his Android phone. So armed with this, he learns that he can do a lot of testing around the APIs, because they're fairly easy to test. Also, he digs deep a little bit into what the backend really is. He learns that there's something called a web server, which is actually responsible for all the web interface communication with the front end. And he learns that there's the business logic is for the application server part of the product is written in WebSphere. And he learns a little bit of Java basics, and now he's able to understand the architecture of the back end, and that gives him an insight into what areas he was not testing or accessing before, which he can test now. And he can also write unit tests on areas which he cannot access from the API or from the front end. Then he learns that there's the database they are using is SQL Server, and he can now, learn to write queries and test his database as well. So armed with all of this information, then he starts off with his testing. Now he moves his attention towards the back end, and the first thing he does is API testing. And he starts with, now he can do module testing and integration testing, which we all have learned but never really understood how to do it. So you start with unit tests, which is unit testing. Then for module tests, how can you isolate a specific module and be sure that you're testing just this module and you're having enough coverage for just one module? From the front end, it's very difficult in most cases. Depends on how your application is, but it can be difficult. So, but with APIs, you are very sure that you are calling just one component. Again, that would depend on how your API is structured, but mostly it's on component to component basis. Or if it's a microservice architecture, that makes things even easier. So now he knows when he calls a function of the API for just a specific component, he's testing that component, and he can add more coverage just around one specific module. Then he can very clearly do integration tests, because now he can add calling multiple modules within one test, creating an integration test. So now he's really excited once he's learned all of this, and now he's able to add more coverage and you can see the results. You can also test third-party services, probably some third-party APIs which his application is using. Probably it's using Google Maps API or something, and he can test that integration. How is it going with his application as well? What happens if the third-party service goes down? How does my application react? Now he has the capability of doing that. Then he moves down the pyramid, and he learns that you can do unit testing and database testing. So he does spend time with the developers on how to write unit tests, or have discussions with them, share information as to this areas we are doing on the API and front end level, these areas you are doing on the unit level. So let's be sure that we are working together and we are collectively trying to add more towards the coverage. Also, now since he knows the database schema, the structure, he can do data validation tests. So he can enter some information from the front end or from the API, and he can go back and actually see on the appropriate, if the information has been saved on the appropriate table and the appropriate rows and columns have been generated. So that makes things even easier. Now there's more confidence in the application. Also, for some tests which previously he thought were not possible, where he needed a lot of test data to be created in the first place and then he could do a test, like for instance, there was something reported where 500 records, if we add 500 records in a specific table, then something goes wrong. So now he can do that just by writing a query which is adding 500 records there. Conversely, doing it from the front end was impossible, because he'd have to spend hours just creating that one form again and again and again and submitting the same thing. So he's happy now. He can do data creation tests, data validation tests, he's doing unit tests, and also he learns that he can do performance testing and security testing, and they would also target different levels across the stack. So now he's really happy, and now he's really putting 20% of his focus on the front end and 80% focus on the back end. So the lesson learned here is to test across the technology stack. Just to add a little bit, I'd like to share a few important and few well-known technology stacks here. So this is the mean stack. All these languages platforms written here are in JavaScript. The front end, AngularJS, is in JavaScript, Express.js, Node.js, JavaScript languages, they're doing fairly well these days. MongoDB, a non-structured database. So, and this is called the mean stack. Similarly, this is as one of a sample. In one way, you can use the Microsoft stack. Microsoft has a lot of offerings, and you can use them very differently. So this is a sample stack from a Microsoft platform. So you have .NET on the back end with ASP, MVCs, and you have SQL Server database, and the front end really don't have anything. You can use, in this case, they're using HTML5. So that's a sample Microsoft stack. You can have a Java stack. So this is on the front end, they have Backbone JS. On the front end, they have, Backbone JS. On the back end, they have Java Enterprise Edition with Rust East, and the database is MySQL. So it really helps to understand what your technology stack is and how it's interacting with one another. Each platform has its own strengths and weaknesses, and you can target your testing according to whatever platform you are using. So I'd recommend to go through this website, stackshare.io, and they have a lot of amazing content. They share the technology stacks for a lot of famous applications that we use, for instance YouTube, Facebook, WhatsApp, and whatnot. So that would be, it's a really interesting area to go through, and so it gives an idea of what's going on in the world in terms of the technology stack being used. Well, for our tester story, now that he's learned a lot of testing, he's learned a lot of he's increased his technical base. But now the problem is that he has a lot to test, and he doesn't have enough time. Previously, he was just doing front end tests, which it didn't take much compared to the kind of tests he does now, because he's added more coverage, but then he also has to do more testing. So the next problem comes, and management says that you need to learn automation so that we can automate some basic areas, so that we don't have to do regression manually every time, and we can focus our exploratory efforts on areas which are more likely to change and need the testing, what I call the testing acumen. Well, so the first thing Asim does is he tries to learn automation. Now for that, he thinks that he can go over different job postings to have an idea of what they're asking for. He can learn that way. Well, long behold, a lot of positions are asking for ridiculous amount of years of experience in a specific language, and have really moonshot requirements, like working with Elon Musk, and some others have listed every possible automation testing tool they could find. And well, some of these really they'd ask you about every possible automation tool in the interview, and once you do get hired, they'll put you on manual testing, which is really bollocks, really. So well, our tester is really confused, and he doesn't know what to do here. So then he naturally turns to our wise testing guru to ask how to learn automation. Well, and our wise man suggests that tools and languages are important, but even more important than that is developing the algorithm design aptitude. So what is algorithm design aptitude? It's the fundamental of programming is designing an algorithm, thinking of how to create a solution for a problem. Now, a lot of us think that we haven't done anything like that, but in reality, if you've played with Legos, probably everyone has, or if you've played any real-time strategy games, then you have done algorithm design, and almost every human being has done some sort of algorithm design activities. And what's common with all of them is that you use small building blocks to construct a solution for a bigger problem. And that's exactly what coding is. We don't code everything from scratch. We use building blocks or methods or functions and libraries which exist already, and we just add them together to create a customized solution for a problem. So the thought process of thinking how to deconstruct a problem and understand and come up with different patterns to solve it and then construct a solution for that is essentially the basics of programming, and that's what we're calling an algorithm design aptitude. Where most people go wrong when they start learning is they go and so this is what I call the algorithm design process. So they go directly from step 1 to step 4, and what happens is that they get lost in between and they find it very difficult. So what I recommend is to follow this process step by step, and now let's go through a sample test case here. So for instance, we are creating a function to calculate a person's age. So how would you do? So the first step is do it manually. So how would you do it manually? We'd think of, okay, so how do we calculate the age, our age? So we'd say today is date X, my date of birth is Y. So you subtract the both and you get the age. Pretty simple, right? Well, so for automation or for creating a solution for our problem, we need to be a little bit more detailed there. So let's write our manual step in detail. So okay, so get the input of the current date and get the input of the date of birth, subtract the both and you get the answer. Well, there is a problem there. So we got the input of 2 apples. We took 2 apples, we subtracted them and we took out oranges out of it. So we took 2 dates and we got the year out of that, which is really not what we are looking for here. So for a computer to understand that, we need to equate everything into the same unit, and that's what the problem is. So this is the third step, which is the most important step, is to write a pseudocode for what is your solution to the problem. So in our case, get the input in date format, and then you convert that date into a day, into the number of days. Then you get the input date of birth in date format, and then you convert that to days again. Now you subtract those days with one another. The result that you have is in days. Then you convert that to years back. So that's how you get years. It was easy to go from step 2 to step 3. Now once you have step 3 listed with all of these steps in sequence, now you can script this in any language you want, be that Python, be that Java, JavaScript, whatever. And now it becomes really a matter of just learning the syntax for the language. So once you try to skip from step 1 to step 4 directly, you're going to run into problems. So the best way is to go through this process, and once you get familiar with it, it becomes your second nature, then things become really easy. An analogy I give for that is, have you ever started to learn driving a car when you were younger? And if you ask someone who is not really a good teacher to ask them how to learn driving, so, and if you were from the good old days where you had to drive the stick shift, so how they drive the car? They just give the ignition and just put the car into press the clutch and just change the gear and off they go. There are a lot of little bit steps in there. So you have to press the clutch, you have to feed the accelerator and leave the clutch slowly, then feed the accelerator, then leave the clutch slowly, so that your car does not jerk when it starts in the first gear. But for them, they do all those steps, but it's become their second nature now, and they don't even realize that they are doing that. It's become their second nature now, and they don't even realize that they have been doing those steps again. And that's exactly what happens with programmers. Once they've spent enough time, they go from step one to step four directly, and they don't have to do the steps in between because they start thinking in the terms of the language itself. And they don't have to think about how to design the algorithm specifically, except for larger complex problems where you'd have an architecture diagram first. So the point being, go through the algorithm design process step by step until you are comfortable with going from step 1 directly to step 4. Also, please don't try to install every automation related tool on the planet right off the bat. I'd recommend to go slow. Start with an easier language. Python is an easier language to learn. JavaScript is an easier language to learn. Java and PHP, for instance, are relatively complex languages. There are a lot of programming concepts, syntactical things, installation, IDE, environment preparation, so on and so forth, which kind of what happens most of the time is people get stuck into all those complexities and they don't get the opportunity to enhance their algorithm design skills. And that's what we want to focus on when we're starting off. So the lesson learned here is develop the aptitude for algorithm design. Well, our tester has developed this aptitude here, and he's getting good with his automation and programming skills day by day. He has the technical background already, so he does not face a lot of basic challenges. But however, he still has started to build up his 9 to 5 into a stressful routine. And let's see why. So when we started off, his perception about programming was that he'd just keep on punching in values on the keyboard and the scripts would be coming along and everything would be so fancy and things would just, like in Hollywood, you would just program stuff and you would be changing the world just sitting behind your computer screen. Well, sooner he hit the reality of it, and turns out that it's not as fun as he thought. And instead of just all the flashy screens, he just keeps running into problems. Every 2 lines he writes 2 lines, then he goes searching Stack Overflow and Google and everything, trying to find the solution for that, and then he has to come back and write 2 lines again, and then the next day he spends the whole day in debugging another problem. That's not a lot of fun for him, and he's not happy. So he was better off with manual testing or exploratory testing because he didn't have to go through all of this over there. And when he does try to solve one problem, he's faced with a lot of other problems. And then finally, when he gets rid of all of those problems, another huge mountain of problems he faces again. So there are just too many problems to handle. So that's why he's in stress, because the problems never seem to end. Now our tester goes back to the wise man to ask of how to deal with this debugging problem, because he can't take it anymore. You just keep running into problems all day. He's just figuring out how to he gets stuck and then he tries to get out of it. So the wise man suggests that he needs to have the right attitude towards solving problems. If you have the right attitude, then you can easily reach to the solution. If you are not coming across you don't have the wrong vantage point when you're looking at a problem, then it gets hard to get to the solution because you're frustrated, you're not paying attention to where it really should be, and you get into a lot of stress. And the trick here is to learn how to control, or the trick to enjoy the process. What really happens when we are in this situation we're trying to resolve the immediate problem that we have at hand. And the notion is that once we solve this, everything is going to be honky dory again, and we'll enjoy the rest of our day. But the reality is that once you solve this problem, now whenever that problem comes up again, you have a program to solve it automatically, so you don't have to do it. But then your work does not end. You are given another problem which you have to solve, and then you are back to square one trying to solve something new. So the problem is, when we approach this with the attitude of just getting over this, that creates frustration because we never are able to get over it because something new comes along again. So try to enjoy the journey. That is the reason why most of us probably came into the software industry in the first place, because it's an exciting industry that you have to keep on learning. You have the opportunity to create new things, to learn new things all the time. It can be challenging, but it's also really exciting. I remember my degree was in telecommunication engineering, and I went with some of my friends to who were working in the telecom industry, and they were working at a BTS site, getting it operational. And what I saw there was really nothing innovative going on over there. They were just configuring existing systems which were in place and just managing people, and that was it. There was no creativity, and that really put me off, and I decided there and then that I'd never go in this industry. And that's why I chose software testing, because it was an exciting industry to be in. I had to learn new things all the time. I was able to create new things. I was able to find new ways to solve a problem. So if you approach debugging with that attitude, to learn new things, to innovate, then it becomes an exciting journey. And once you are happy with the journey itself rather than the end goal, you start enjoying the process. And that really makes a big difference, and makes your 9 to 5 really wonderful. So the lesson learned here is to develop the right attitude towards debugging and to enjoy solving problems. So our tester Asim has learned these different lessons over the years, and now he goes back by his testing guru to let him know of all the adventures he has gone through, and he suggests him to recap all that he has learned. So the first thing Asim has learned here, or he learned through stories, is to be a technical tester, to be technical. If you are just doing functional black box testing, you won't go far. You will not be able to reach decent code coverage or test coverage for your application. The second lesson is to learn the technology stack of your product. How the UI front end is working, what platforms they've used there, what's the backend made up of, what's the architecture, what database they're using, what's the architecture over there. So all of this gives a lot of insight, and you have then the capability to test at the API level, the unit level, the database level, and you can do a lot of tests which might previously be almost impossible to do from the front end. The third lesson we've learned here is that we need to develop the aptitude for algorithm design. That is the fundamental crux of programming. If you have that aptitude, then you can learn any language, any tool, because the languages and tools will keep on changing over the years. They're never going to be constant, and they should not be, nor should you. So the real fundamental is the aptitude to train your mind to think of algorithms to solve problems. And the last thing to enjoy the process, enjoy solving problems, because that's what we are here to do. We are always solving a new problem. So if you enjoy the journey, then you have a wonderful time. So Asim is a technical tester, and be like Asim. So thank you for watching the presentation. I hope you enjoyed it. And to learn more about how to become a technical tester, do visit qualityspectrum.com, and you can follow me on LinkedIn. I'm active there, and I'm also adding a link in the description below from where you can get the slides for the presentation. And thank you once again. See you next time. If you have any questions, add them in the comments below. If you find this video useful, please don't forget to like and subscribe to the channel to join us in redefining software quality.